Hello everyone. I'm going to talk about how we can work on pandas. This is a library in Python. So you can see that I added a picture of panda, not pandas. So you can see it's actually taken in San Diego Zoo while I was there in 2018. And then we were allowed to take a picture, but we have to pass along this route. So I was a little bit away from this panda. Okay, so the learning objective for today is how we can create some data series, create data frame, and then subset our data, and then convert them into a data frame using pandas. We can also access using indexing. The indexing we did months ago, so you saw how we can index, and also every week we are also subsetting our data by indexing them or locating our required columns or the rows you want to select. Also in pandas you will be learning how we can handle data set. Let's say we have different kinds of data in different formats. Let's say in Excel format, in CSV format, in text format. You can bring in those types of data into Python IDE. We will be using Jupyter Notebook, so you can bring it into Jupyter Notebook and then summarize the data, and then you can also import the dataset that is freely available. People usually use for example, people usually use the IRIS dataset. You will see that in machine learning, in data sciences, people popularly use this dataset. We will be using that. And how we can extract information in a dataset, how we can select certain amount of variables and then rows, how we can add conditions also whenever we subset the data. Or let's say we have a really large data set and then we are not interested about all variables, or maybe not interested about all records, then we can select using the data conditioning. Then you can say that yes, these variables should be larger than some value or smaller than some values. Or maybe we are interested in one kind of species or a few kinds of species. Then we can add conditions, and we can add multiple conditions. We can add single condition, or we can do it by steps. Add first condition, and then in this second data set we can add second condition. So after data conditioning, then you will be learning how we can plot our data so that we can create different graphs. Graphs includes density plot, histogram, scatter plot, box plot, and you will see a few more graphs we can create in pandas. You can do a lot more thing in pandas, but just I added a few examples in there. I also added few data sets so that you can handle different data set, and then summarize them, condition them, and then you can create some graphs as well. So more references are provided here, so you can take a look at that site. Also there are many pandas examples available out there. Also in the syllabus I provided you some. So basically in pandas we try to convert our data set into pandas form so that we can easily and then really fast and flexible way we can handle our data set. Because otherwise, why we are not just bringing in the data into Python and then directly analyze them? Because it takes some space, it takes some time, so that we can reduce the size of your data set and then convert it to a form where we can flexibly handle our data. Also, we would like to do some data analysis as well, and we can do some statistical analysis as well using pandas library. So you will see that there are some functions that is only available in pandas that we can use within pandas environment, that doesn't work outside pandas. And And then if you want to look for similar functions outside Pandas, then you need to look for those. I just included what we have in Pandas. We are converting them into a data series. So you can read these materials over here. So how we can convert it, because everything will be in, usually we use the maybe one-dimensional or two-dimensional, but you saw in NumPy we can have more dimensions. But over here we are not going more than 2 dimensions. So we can use Panda series because I gave it a short name. You can see whenever we are installing libraries, we are giving it a short name. So short name is PD. You can see Pandas, we are calling them as PD, and then I'm saying that PD use the series, and then what's the data set, and then what are the elements we are going to extract. So you can index them within your data set. There are a few more libraries that you need to install. I install all of them so that if I need to use them, I can directly use it. Otherwise, whenever you need it, if you want, you can just add them wherever you need them, because we don't need at first the matplotlib. Later on you will see that I'm using matplotlib. We install all of them. Let's install all libraries, and then import Pandas. You can do it in one block of code. I just separated them just to show you. So over here you can see that just like I showed in PD series, you can call in the data and then what are the elements you are going to extract. So I added a Panda data series. So you can see I added, just like you learned in dictionary while you were creating list, tuple, and dictionaries. So I'm doing the similar one. You can see I added curly bracket. In this curly bracket, I said first one will be Panda series, where we will have the values 1, 2, 3, and then each of them have a name. That means you can see one, I'm calling it in rows A, and then rows B and rows C. And then in second data series, we will have 1, 2, 3, 4. That means we would have one more that's not available. The last one is not available in the first series. Then it will think that it's actually missing. Let me show you how I build that. So you can see that first one we have A, and for A, index A, we have the value 1, and then that way B, C, and then you can see the second one we have the 2. Within 2 we have A, B, C, D. That means we have 4 values in there, 4 rows we have. Now we are converting it into a data frame. You can see from the dictionary style, we're not sure how the data looks like, then I'm converting it to a data frame. Okay, so when I convert that, you can see that we have 1 and 2, or if you want, you can move it other ways. So you can see in column, first column, we are calling it 1, second column, we are calling it 2, and then each row we have values, and then you can index them by using A, B, C, D. And the last one, as I said, we don't have the value. It says that it's actually a not available. That means missing value in there. You can access the indexes. So you can see that what are the indexes we have. That means the data dot index. So you can see that it says that indexes. That means since we gave them a name, those index. Usually we call them 0, 1, 2, 3, 4, but we are calling them A, B, C, D. That's what you can provide. So it shows that you have 4 indexes, and then in those indexes we have A, B, C, D. And then I say that what are the names of the column. So it says that 1 and 2 are the names of the column. Okay, so we are going to access those data set. We are subsetting them. So we say that give me the first row. So it will always give you the column name, and then since you are accessing the from 0 to 1, that means it's giving you the 0 row. And then if you say no, start from 2, then it will start from 2. This is 0, 1, 2, that means C and D. So you can see C and D. And if you say nope, start from 1, that means it will start from 1 and then it will give you the rest. So that's how this indexing works. So in this example, you can see that I created another Pandas series. That means the data set. So you can see here we created the data set. Then we said that print the value, that means the data set we created. So it says that you created a data set S, and then S has these values. So values are added, and then you can see since we did not add any name for those indexes, it just gives indexes from 0 to 5. And then I said that what's the range. So if you want to add the dates, so I said that add a date 2013 and then 1st January and then period 6. You can see that it adds from 1st January up to 6th January. So you can say what's the period you want. So that's how we can work on the we can create a date range. That means the type of data set, date and time. Different types of data I created again using tuples. So you can see I added the column names, and then I added the indexes, everything. And if you print them, you can see that D1 has this value. So it has at first 3, and then it has 4 as well, and then I added them too. So you can see you can create, I did not create, but you can create a data frame. So over here I said that create a data frame, and then I added everything. I said that column list, rather than saying it separately, I added them together. So I said that XYZ is the column names and then indexes are ABC. That's easier to add. So the first series, second series, that means these are the for XYZ, you can see what are the values would be there. So that's why you can see I created data 1 and data 2, and then I added them together using append. This is a function in PD, that means the pandas, and we created a data frame. So we say that create a data frame and append them together. So over here you can see XYZ is the column name, and then we have the indexes, and then we join them. At first we had ABC, now we added DEF. So I added an activity for you. So I said that create a data frame from an array of 10 random numbers. That means you have to create a data frame where you have to add 10 random integers. So you can create your own and then display this data frame. That means you need to print them, just like I printed them in here. And you can create a data frame from a list of numbers between 1 to 10 and then index them by list A to Z. So that's the objective I gave you. It's a really simple one. And then how you can add random numbers, random integers, you need to think about that, how you can do it. We created random numbers before, we generated them. How we can do it in Pandas, and add to the previous data frame a new column. That column should have values from 11 to 20 and display them, display this as a data frame. So you can see I already created that. I did not give you the result, the code. So you have to create your own code. And then you can see that I created a data set where I have indexes A to Z. I created another index A to Z. And then you need to join them. You need to append them together. So you can see I did it in different ways. And then the second method, you can see I added the columns, the column 1 and the new column. So I added the values, the random numbers, in the first column. In second column, I added the values from 11 to 20. So first one, I added 10 values. Second one, I had 10 values. But then again, first one is just the random numbers. So that's what I ask you to do in here. And I also gave you the example data set. In this example data set, we have some tree information from a planting site. In those planting site, we have species information, we have DBH, we have heights, and we also have serial numbers. So we are bringing in the data, the CSV file we have. So you can see within Pandas, you can use the read CSV, and then using that function, you can bring in, and then I printed out the data set in here. So that means we have the IDs, species number, DBH, and height values. And you can do some and create some summaries of the data. If you have really bigger data set, then it's not a good idea to print everything. You can just look at the first few values and last few values, and you can summarize them. So to summarize them, you can use the name of the data, then describe. So you can say describe them, and then if you only say describe and then leave it blank, it will only give you for the summary of numerical variables only. If you need the summary of numerical plus the character variable as well, if you have any character variable, we do have a character variable species in here. So that means you need to include them as well. If you want to, then you have to use include all. Then it will give you the summary of all variables. And then if you want to extract first 10 rows, you can say head, and you can say tail to see the last 10 rows. So you can see I did the same in here. I described them and then summarized them only for numerical variable. Then I added for the species variable as well. So you can see species variables, when we have that, it only gives me the count because it has no numerical value. It cannot give me these statistics. It's only giving me what's the count, what's the top value, and then the frequencies we have in one of them. Okay, so if you need to see the last few columns or first few column, then you have to say use this data.tail or data.head. So let's say we would like to see what we have. Let's bring them here. Okay. So you have to name the data. So name of the data is FTD, and then let's say I would like to see the last few columns. I say 10, it's not always 10. I only giving me, I just give you an example. So it's giving me 5 of them. Okay, similarly you can say ask for head as well. So now we have the Irish data that we would like to work on. So you can see that this is really popular data set I mentioned to you before in data science and machine learning. Later on we will also use this data set. So in this data set we have 2 of the 3 species. So you can see we have 3 species, and we have the information of their the width of the length and width of the sepals, and then petals, and then it's everything all are in centimeters. So that means we have the petal, their number, and then their length, and then their width, all of them. So at first we need to install the Scikit library because and then sklearn. So you will see that popularly it's being used in machine learning in data science. So I loaded everything just in case if you did not load it properly, or maybe you stopped somewhere. So you can see that I loaded the data set as well. It's available online, the Irish data, and then I say the load everything, load the data, and then I added the names, the column names as well. So I gave it a name data. So you can see you can extract the arrays like we used to do in NumPy. So you can see the array 1 to 10 what we have. So I say that I would like to add the column names. So you can see I added the column names. Then I say that give me a description of the data. That means give me all of them. So we have sepal length, sepal width, and petal length, petal width. So you can see what's their minimum number, maximum number, what are the how many numbers we have, what are the averages, all of them are there. And then I added the first 5 and then last 5, so you can have an idea of the data set we have. And then I say that in the data set we would like to use the names of the species, because on the first column we have the species but we did not say which species it is. So I say that how about add a column instead of 0, 1, 2, add a column and then say the names of those species. So you will see that that's why over here we have, previously we had the we don't have the names of the species in our dataset. Now we say that based on the coding, we added the names of them. So the last few and then first few, and then you can see that we added the names. After adding that, let's say what is the target. So you can see that in the target, that means the name, instead of name of the species, we had the numbers. That means 0 is for the first species, is the Setosa, and then versicolor, and then virginica. So all of them we are using. So that's what we have in here. 3 species. Okay, so we can also get some basic information. So you can see for the basic information, let's say we would like to know the number of rows, number of columns, indexes, columns, and in the data frame, what are the information we have available, and then few more of them are here. So I added a few, you can find more. So I just wanted to show you as an output what we can get. So you can see that if it is shape, then it says that how many rows, how many columns we have, and then how many indexes we have, and information. So you can see I also added the info. It says the information we have in there and how many counts we have. So the counts of each of the species. So it gives me, it says that 150 variable, 150 rows, that means counts we have in the data set. So you can get more. So you can see I said how about sum all of them. That means for each of the variable it will give you the sum. This is giving you the last one because I did not ask it to print. So it says that the median value for each of the variable is are these. So you can print them if you want to see any of them. Then how we can select the data, it's similar to what we use in indexing. So if you want to see all of them, then you can just add this bracket. It will give you everything in there. And then you can, if you want to return all columns and all rows, rows from 10 and above. Also, if you want to specify a specific variable name, or you can say no, slice by indexing, and then give me the first set of numbers. That means you can use log or you can use ilog. You can investigate them. So you can see if I say from 1 to 10, it gives me from 1 to how many we have in there. That means it's giving me up to 9 because it's not going to give you all of them. The last one is 9, and then all columns should be there. If you only need one of them, then you can see that it's only giving you sepal length. So for the sepal length, so you can see that it's only adding the sepal length. First view and last view, it's showing you. And then, okay. So if you say getting one value from one value, that means the you can see that the one of them will show up if you just maybe rather printing. So you can see it's only giving you one value from the sepal length. That means the first one it's going to give you, and then if you say 0, it will give you this number. That means that's the 0 index, 1 index, 2 index. So you can specify which one you want. If you want to see more, then you can see that from 0 to 6 rows, and then column number 1, 2, 3, that means the first 2 columns is going to show you. So in activity 2, I ask you to select the rows in the iris data from the data frame. So you have to select the sepal length where it's more than 6.5, and then the other variables I added conditions. The thing is, you have to, at the end, you should have a data frame where you satisfy all these conditions. So you need to think about how you can satisfy all the conditions. So you will see that I added an example in here. For the solution I gave you, only add the first one I added. So I said that if it is more than 6.5 for the one variable, so you have to do the other one. But then again, you have to think about at the end, you need to have a data frame where it satisfies all of them. So you can use AND, you can use OR. So you can see that I added an example for you. So where I said that if I want to add everything, that means if I want to add both conditions, then I have to use AND. If I want to satisfy one condition, actually no, it's actually satisfy either of the condition. That means it could be greater than 5.7 for petal length, or it could be petal width would be less than 2. So that means you can satisfy either of the condition, then you can add OR sign. So you can add similar ideas for solving the activity 2. So I hope you can do that. I'm just showing you one of them. So the last item for us is how we can plot them. So you can see that we have the plot option. So we can use the plot area, and then you can also plot. This is the usual plot. You can see that we are not using the PD. So you can create an area, and then area of all variable. We did not specify which variable, and then we said that also give us density plot, bar plot, histogram, line graph, and then scatter plot, x-axis versus y-axis, and then bar plot, box plot, and then hex bin. So you can see that just like in hexagon, it will give you as a grid size 15. So you will see that one by one all of them is coming. So this is so big, that's why it cannot show everything in here. So this is the area graph. So under the area, what we have, and then we have the density graph of all variables, and then the histogram, line graph, and then the scatter plot. So I say that specify which 2 variables I would like to see, and then you can see the box plot. You can see the petal length depending on the grid size. So if you want to create a bigger grid size, you can add the grid size, or smaller, you can say that. And then you can see I also plotted them using the plot histogram. I just plotted separated them, all columns and all histograms are there. And then I said that if you want to rename, you can also rename one of the variables. So you can see I renamed because there were some spaces. If you want, you can also rename them, just like this one. And then I also gave you another activity. For this activity, I gave you the solution. If possible, do not see the solution, read them and see that I asked you to create a box plot of the iris data, and then I gave you the detail, what to add in there. In is capital, it should be small. Okay, so you can see how I created it, but you can create your own. Let me show you the box plot. And then I added the color of those histogram, and specific color, and then using the hexagon, and then I created the data, and then I said that depending on what's the species it is, 3 different species we have, and then give me different color. So you can see how I added different color for different species. Here is another example where I gave you Haida-Gwaii data. So in Haida-Gwaii data, we have some planting sites, we have information of species, and then heights, and then deviation. We have a lot more information. We also have their ages. So that means you have a bigger data set, so you can specify what you are interested about. So I say that, how about give me the old growth, where we have the ages of those trees more than 100. That's a really big one. And then I kept it within the folder where I have this Jupyter file, Jupyter notebook. Then I don't need to specify the location. Then I said that just like in R, maybe you saw that we use the double equal. That means the species should be cheddar, and the species should be maybe you can say hemlock or maybe other types of species. So you can add that. And then I said that give me a plot. This is more like using the you saw that in Matplotlib how we plotted them. So I just plotted in a similar way. So different ways I showed you we can create some graphs. So you can see how we can create using Matplotlib, so that you can compare them. Okay, so that's it. I hope you will enjoy this Pandas notebook. I gave you different examples, but you can explore more. So I gave you at the beginning where you can find more. Thank you. That's it for today.